So guys, in this lecture video, I will going to discuss the reference counting problem in general and what is the solution of it. So when the application has a multi-reference object, then such an object must be freed only when it is no more referenced by any other object. Take it as a thumb rule. So let us try to understand this with the help of a diagram. Suppose your application has an object A and the object B, C and D holds a reference or pointer to the object A. Alright, the object B could be some other standalone object, object C could be some linked list, and one of the node in this linked list holds a pointer to the object A. Similarly, object D could be a binary search tree, and one of the node in this binary search tree holds a reference or a pointer to the object A. Alright, so if your application tries to free the object A, then it would result in the problem of dangling pointers. The object B will point to the object A, which is already freed. It simply means that this particular pointer becomes dangling. Similarly, one of the node in the linked list C refer to the object which do not even exist. Again, a problem of dangling pointer. And the same goes with the object D. In fact, your linked list and tree data structure are said to get corrupted. Alright, so solution to this problem is that the program must destroy the object A only when no other object has a reference to it. Even in real life, you will discard the thing only when it is of no use to anybody. Even in real life, if some object is being used for some purpose, you would not discard that object as a waste object. Alright, so the solution to this problem is referred to as reference count solution, or you can say reference count is a concept. In reference count, you need to maintain an integer called reference count, it could be any variable name, for the object which is a multi-reference object. So here the multi-reference object is an object A, and one of the data member of this object A is ref count, which is integer type variable. And this variable keeps a track regarding how many other objects are referencing to A. So in this case, obviously its value is 3. Now, when you malloc the object A, initialize the reference count variable of the object A to 0 and increase the reference count of the object A when some other objects start referencing to the object A. And for that, you can use an API reference A. Alright, so as soon as you create some objects, let's say object B, and object B start referencing or holds a pointer to the object A, immediately after that, you need to invoke an API reference A, which will increase the reference count on the object A. Alright. Similarly, if there exists an object which stop referencing to your multi-reference object, then do the opposite thing. You need to invoke an API dereference on the object A so that the reference count of the object A would get decreased by 1. And you have to do an additional thing that if the reference count of the object reaches 0, then only you free the object. Alright, so this would take care not to delete the multi-reference object as long as it has been referenced by some other object in the application. So you should free the object only when reference count of the object A reduces to 0. And one important thing to note here is that for such a multi-reference object, you should never free the object using direct free call, but you should always rely on dereference API call to free such objects. In many large software projects, there exist multi-reference objects which are being referenced by n number of other objects in the application. So for those multi-reference objects, you have to deploy the concept of reference count to avoid premature free or release of such objects, and thus avoiding the problem of dangling pointers.